So today we're talking about assembly drawings. Question one is, what's an assembly drawing and why do we need it? It's a drawing of an entire machine, or sometimes I guess a station would be considered a sub-assembly, but it's still an assembly. So the assembly drawing is a drawing of the entire machine with all of its components located and identified. Again, if you have a big machine with a lot of sub-assemblies, generally speaking, you would list the sub-assemblies as major components of the overall assembly. And then within each sub-assembly, you would create another assembly drawing and list all of the components that make up that assembly. And if you have more sub-assemblies inside that sub-assembly, you do the same thing. It's just kind of migrates on and on. So it lists all of the components, and then it also gives you instruction on how to assemble the machine or put it together. Hence the term assembly drawing. If you looked at in the old days, when everybody was drawing on a board and a designer or an engineer came up with a machine design, the initial drawing would be called a machine layout drawing, because it would not be an assembly drawing. You couldn't really, it wouldn't have balloons or bill of materials or dimensions to assemble. It might have some dimensions on it in order to make all the parts, but they would be called a layout. And then once everything was detailed, the layout would be turned into an assembly drawing. So that would means it would be finished out with different, extra views, the bill of materials, and all of the ballooning, whatever other information, setup dimensions, which might not be shown on the original drawing. So it's kind of evolved over time, and layout drawings aren't really done so much anymore. They're in the process of designing the parts within a CAD program. A lot of times the engineer or designer is making the assembly drawing as he goes along. Back then it wasn't. It took up too much time for the engineer to do a complete assembly before he handed it off to detailers, to create all the detailed parts and their drawings. So that's kind of fallen by the wayside. So now basically everybody just does an assembly right from the get-go, because they have to, even just to create enough information on how the parts fit together for somebody who's creating the detailed drawings to determine what's important surfaces, for example, what tolerances should be, things like that, stack up information. The detailer needs to see all that. And that's part of what is kind of interesting about assembly drawings, is that's where you find it. I mean, so if the designer, for example, holds say the dimension from here to here tightly, well, then that helps the detailer determine how much tolerance he's going to be able to have on the thickness of this part and this part. This, what appears to be maybe a spacer or something in between, or a key. It looks like, I see we're looking at shafts, not flat pieces, but just the same. It gives the detailer an idea of how much leeway he has in what surfaces he may have to hold close for assembly. So, like I said, in this case, we're looking at a coupling that's basically coupling two shafts together. So they're not flat components, but we get that idea, through the views. The section view, with only the section view, for example, you couldn't necessarily be sure what you were looking at. Obviously, this view helps because we can see everything is cylindrical. But the assembly drawing doesn't define the features of the individual parts, so there's no detailing of individual parts on the assembly drawing. And a subassembly is kind of like I stated before, is two or more parts that form a portion of an assembly. Some examples, like the car is the overall assembly, then the engine would be a subassembly. If the bicycle is the overall assembly, the derailleur would be a subassembly. The compressor, the AC system is the overall assembly. The compressor is a subassembly. As would be many other things. So the parts of an assembly drawing, basically just three parts, right? Not parts that make up the assembly, but things that make up the drawing. We need views of the assembly itself. We need ballooning to tell us, which are the individual parts, and then we need the parts list to describe those individual parts. So we identify the various parts with the balloons, with leader lines that point to the corresponding part. And again, if you look on this drawing right here, number 1 points to the top plate, and the find number is the same. 1 is 1. Quantity required 1. The part number is 2314-1, the material, and the description. Number 2 points to the bottom plate. So in the parts list, the item number or find number is 2. That's the bottom plate. 3 represents the pin that basically pins those two plates together, locates them. So the balloon number corresponds to the item or find number in the bill of materials. Again, this is something that SOLIDWORKS pretty much does for you automatically. It says that balloons are placed in orderly horizontal and vertical rows when possible, but that's not always possible. Sometimes you need to put them in different order, make them more circular, so that you might need to have some up here or down here. They can be square. Wow. And then notice how the section view, when it cuts this, it actually exposes items that would normally be hidden. And so generally speaking, you don't want, like dimensions and leader callouts, you don't usually want to define parts in an assembly by pointing to hidden views. So if you've got parts that are internal into the assembly, you need to cut some sections so that you can expose those parts and you can expose those parts and then balloon them. Leader lines shouldn't cross. They should be parallel to each other when possible. Notice in these other views that they're not exactly parallel. Could they have made them all parallel? Probably, but they didn't. Again, SOLIDWORKS probably tries to start out that way, but you can maneuver things around. You'll see when we do this assembly how things play out. How do you know the details of the parts on the assembly? The bill of materials calls that all out for you. It gives you the quantity, its own unique part number for each part, which is usually defined in the detail drawing. So part numbers usually correspond to the drawing numbers of the details of the parts. The description usually corresponds to the description of the part or the title of it, also in the drawing, the detail drawing. And the material is material that would be called out in the part file itself, say in SolidWorks, not the drawing file necessarily. It's going to pick up whatever information is available in the part. So if you don't have material called out in the part, and you're not accustomed to adding material in the part and doing it on the drawing, you should probably work on changing that. Because I think the link to the property is in the bill of materials for description, material, and part number all come from the drawing. They come from the drawing file, I guess. But I thought that this came from the part itself. I guess we'll have to maybe do some experimentation and see how that works. Normally, material call out on a drawing is automatically linked. Most companies set it up in advance so that the material call out in the drawing is directly linked to the material of the part. So that's the property that the drawing's looking for, and then that would be the property that the bill of materials is looking for. We'll have to do a little experiment to find that out. We'll take away the material on one of the parts and we'll see what happens. Okay, so what are some guidelines for creating assembly drawings? Should show how the individual parts fit together, not how to manufacture them. They shouldn't be cluttered. You can eliminate lines and features. Usually you don't show hidden lines, except when it says, when it's an issue of clarifying what the part actually looks like. No hidden lines in section views, and dimensions are not usually included unless they represent a function of the assembly. So what that means is, if you, again, if we were to think about stack up, you might put some dimensions on, say, an assembly or a group of parts, and say, hey, this dimension can only, vary within these parameters, plus or minus whatever. So when the assembler puts these parts together, he can do a check when he's done and make sure that they fall with the overall dimension falls within their range. If it doesn't, then he knows he's either got a bad part or something's amiss somewhere. There's dirt, if it's really close, maybe there's dirt between parts or something like that that's causing a small gap and increasing that dimension, whatever the case may be. But so let's go back and figure out if he's got a bad part, which one it is. Location dimensions, setup dimensions, things like that are included. But if you've got a machine with a number of inline stations, you might want to put some dimensions on it to locate the centers of each one of these stations, so that when it's assembled, they have a reference points to start from. When assembling it all and doing some checking to make sure they've got everything right, things like that, but not dimensions on how to build the parts. Okay, that's it for this pretty much. All we're going to do at this point is download the assembly drawing if you haven't already, and see if we can create some views. So I'm just going to escape out of this guy for now. Here is the project, the in-class project. And this is what it looks like when you open it up. And it's got all these, Bob, have you got them all downloaded? You do. Angel, do you have them all downloaded?
Yes.
Okay. So I don't really need to go through this. I actually go through it on the part 1 video that I did already. So we don't need to spend too much time on that. For me, I just went ahead and downloaded everything into this folder, so that it's all in this folder on my desktop. Should I work in Angel? Do you have SolidWorks loaded, or are you working with AppStream?
I have it downloaded onto my computer.
Okay. And again, I already went through this with AppStream, so I guess in the first video, I showed them how to upload to the home folder and actually get started, I think. So I'm going to just go ahead then and this time do this one in the native install of SolidWorks on my PC. And hopefully it won't take as long to load as it does when we're doing the AppStream version. Okay, so I'm going to open my drawing file, and if I look at my my desktop and go to assembly files, all I need to do is really is open the C-size drawing. I don't need to open any of these other parts or sub-assemblies or the main assembly, because everything's in the same location. So I should be okay. If I open the C-size drawing, since it's a template, I'm just going to go ahead and save it as a I thought it was going to ask me where I wanted to save it, but apparently not. So I'm just going to save this as MET 100 assembly drawing. And so that preserves my template in case I need it for something else or somehow lose this one. Okay, so I want to bring in views of this guy. I'm going to use the view palette like I normally do. When I look in here, though, I've got no parts or assemblies to look at, to choose from. There's nothing open, so there's nothing showing up in here. So if I go to the browse, it's not working, and that's happened to us before too, hasn't it? Where that didn't work. And see, now I open it the second time and now it's highlighting. So if I browse, and again, just to prove my point, hopefully, when I select this guy, it's empty. The drop down is empty. I don't have anything open. So I'd browse, and I want to browse. I'm going to browse right back to this assembly files folder because that's the path that it knows. And this is the overall assembly. So I'm going to say, yep, I want that, because here, if you look at these other sub-assemblies, you've got the handle and this insert. You've got the clevis and the clamp. And then here you've got the bolt and the washer. And then if you look at this, it's all the individual parts that make up those sub-assemblies, which make up the overall assembly. So I'm going to pick the main assembly, the O1 assembly, and say open. That's not going to bring in any, it's going to bring me all the views that I need for this guy. And does the let me go back to the instructions here. Um, it says create an isometric view and an isometric exploded view that shows how the assembly goes together. So the first thing I'm going to do is I'm going to start with my exploded view. I just happen to have one. How nice, right? But if I pick the isometric and bring that guy in, I should be able to explode this view without having to pick that exploded view. But when I look at the property manager right here, it says show an exploded or model break state. So if I just select that check mark, the checkbox, then it explodes the assembly for me. And the reason I can do that is because in the assembly file, someone created an exploded view and saved that as a configuration. And that's what it's doing. It's just looking up that particular configuration. So either way, I could have picked this and it would give me the exact same view. See that? Exact same view. And that one I can unexplode if I want and bring it back to that particular state and say, you know what, this is going to be my isometric now, and I'm going to make it like we make all of our ISOs. I'm going to show it shaded with edges, and I'm going to change this guy scale-wise so that the scale is a little bit bigger. I'm going to go 2/3. I'm not going to go 1:1. Probably could, but that's probably good enough. So there's my exploded view of the assembly, and my unfortunately this guy is aligned with that, which I may not necessarily want. So if I just right-click inside the view, go to alignment, and say I want to break the alignment, then I can move this wherever I want. So when I brought it in, if I didn't align it like I did before I dropped it in there, it wouldn't have aligned itself. It would be just like it is now. So no problem. Okay, so what do I have left? I mean, it says create a bill of material table and create balloons identifying the connecting the parts with the bill of material. So does it matter which one I do first? No, not really. So I don't know which one to do first. Let's do the bill of materials. I normally would do the ballooning first, but let's go with the bill of materials. So it's under annotations, tables, and I click the down arrow, and the third one down is bill of materials. And it says select the drawing view to specify the model for creating the bill of materials. Well, this is the one I'm going to put the balloons on, so I'm going to select that one. Could I select this one? Probably. I don't know why, you know, it probably wouldn't matter, but normally, a lot of times, you wouldn't have this view in there to begin with. So I'm going to select this view. And then it gives me some options here in the property manager. Do I want to do a standard, you know, it's a standard bomb. Do I want to attach it to an anchor point? And you know what? I don't think I want to do that because I might have to move it at some point. I might want to show it attached to the title block down here, or you know, and then save room up here for revisions to the assembly. Or I could put the revisions down here too. Either way, but generally speaking, yeah, it probably would go up here in the corner. Could go in this corner if you've got room. That's not an issue either. Again, like I said, if you're going to add a revision table or a revision block, then you might want to put that in the upper right and put the bill somewhere else. It can go here, here, or here, or there. Top level only, parts only, or indented. Let me insert it, and then maybe we can see the difference. Configurations, actually, most of this stuff I just want to keep as whatever the default values are. Text format, all uppercase. I might go ahead and check that just to make sure that if I type anything in, which I usually shouldn't have to, that it comes in all uppercase. And all I have to do basically is hit the green check. It's kind of like doing a revision block, except the revision block would kind of jump right in there right away, I think, maybe. I don't remember. But in this case, once I hit OK, it's now attached to my, my cursor. So I could set it up in this corner, in that corner, down here, here. A lot of times if you do it, see, it doesn't automatically attach itself to that corner right there, but it probably will. Yeah, maybe not there either. So what I might want to do if I was going to put it down here, I might want to change the order and put the title line for item number, description, or part number, description, and all that at the bottom, and then have the numbers run from bottom to top. So I'm going to just put this guy up here for now. So if I zoom in here, here's where we have the part numbers are the sub-assemblies. And then one part, and that's the nut, because everything else that's in here is a sub-assembly. Remember, this is one sub-assembly, this is a sub-assembly, this is a sub-assembly. The only thing that doesn't have more than one part to it is the nut. So when you look at the bill, the bill, it's all it lists is the sub-assemblies. So what happens if I now select this guy to get my property manager up here, and it says top level only. If I say parts only, well, now what it's going to do is it's going to list the parts that make up everything, but it's not going to list any of the sub-assemblies. See that? It's all parts. 1, 2, 3, 4, 5, 6, 7. And then we've got how many cap screws? 2 cap screws, 2 washers, right? That's correct. 2 cap screws, 2 washers, 2 nuts, and then should be basically one of everything else. Now, if I change my my bill to indented, now what it's going to do is it's going to show the sub-assemblies and then underneath list all the parts for that sub-assembly. So the boom's made up of the boom and the swivel adapter. The fastener is made up of the cap screw and the washer. Notice there's 2 assemblies required. And then within each assembly, there's 1 cap screw and 1 washer. So you don't list the total number of parts when you do it this way. You only list the number of parts that make up the assembly. And so that the person reading this should understand that and know that if he's got 2 fastener assemblies, he needs 2 cap screws and 2 washers. So there's my indented bill. I still only have 4 item numbers though. See that? Only 4 item numbers. Let's go back to our original insertion of top level only. So now we've got, again, we've got the 4 item numbers and no part numbers listed. So now we want to balloon this thing. So let's take a look at how we do that. It's pretty easy. Just like the bill of materials, I have 2 options. I can do my ballooning manually and pick each individual part, or I can do it auto balloon. And 99.9% of the time, you're probably going to auto balloon it rather than do it manually, taking the chance, especially if there's a lot of parts or sub-assemblies that you might miss one. So auto balloon is probably the best way to go. And if you look, now we've got balloons on here. They're highlighted. They're not done yet. But the default was a square layout for the balloons. There's only 4 of them. If we want to go to the balloons on the top horizontally or the bottom horizontally, we can do that, or to the right or to the left. It's all doable. But you notice, hopefully right away, that we've got issues with the leader lines crossing other parts, which is kind of a no-no. Yeah, definitely we got that situation here. And this guy is like way over here, you know what I mean? That's a pretty long leader line, when I could just as easily move it, but I can't move it. I can't right now. They're all related. So if I move one, they all move. So what could I do? Could I put the balloons in like this and then take this guy? Now, see, I still can't move them individually. So let's go back to where we were. Like so. So how do I, what do I do with this guy? How do I deal with that? Well, let's get to that. So right now, let's look at my balloon layout here. This little symbol underneath here is not of any consequence right now. It won't show up when once we're done placing this. But I want to show you some changes I can make. If I don't like the size, I can change the size. I think I might have to do that in the settings, or if I don't think I can change the size of the balloons here. I think I have to do it in the settings under document properties. But I can change the type of balloon. Right now it's just circular. I can make it a triangle, make them all triangles if I wanted. Hexagons, boxes, diamonds. There's a specific use for each one of these. When you're calling out parts on an assembly drawing, usually you use circular. Sometimes some people prefer to show a split balloon, which has two characters in it. One would be the item number on the top usually, and then underneath might be the quantity. So I can go to circular split line down here and say that's what I want. And now if you notice, they all changed to, they got slightly larger. They all changed to circular split line, and they all show the quantity underneath. And of course, quantities are 1 for everything except for this guy, it's 2. And so it shows the correct quantity. So when I'm done, let's see what happens when I'm done. I'll just hit the green check. Once I've placed it and I'm done and I hit the green check, now if I need to modify locations, I can do that. For example, this guy, I wouldn't leave him there. I'd probably put him like this. If I leave him attached to this nut, kind of presents a problem with where am I going to place this guy, What about this is a subassembly, right? And so this is, for whatever reason, it chooses this one to point to. But if I were to take this and remove the arrow head from that part. Let me just put it out here in the middle of nowhere. See what happens to the balloon. Now it doesn't know what we're pointing to. It doesn't have quantities or part or item numbers. So it just gives me question marks. And again, if I put it back on here, that's 1 and 1, right? So what happens? It's item 1 with a quantity of 1. What happens if I put it on this guy? I'm going to put it right in the middle here. Notice it changed to a dot. It still shows 1 and 1 because it's part of that subassembly. So I'm still pointing to the subassembly. I just don't necessarily need to point to this part. So if I take this and move it, say, to here, that's a little bit cleaner, isn't it? I can move it up a little bit so I'm a little more parallel with this guy. And move him down. But I can do the same thing with this one too. I can change it since it's pointing all the way over here. I don't need to point to this washer and cross these two in the process. I can just go ahead and point to this one fastener, and it's still the same information, right? When I look at the bill of materials, nothing's changed. It's still the fastener assembly, and I still need 2 of them. So all of these adjustments are available for you. So let's take a look at the bill again and go ahead and highlight it. And now let's go to from top level only. Let's go back to parts only. Now I've got 7 parts listed on here. What happened to my balloons? Did my balloons update at all? No, they didn't. They didn't update. So what happens if I eliminate them all and then re-auto balloon it? So now that I changed this to all parts, my balloons didn't conform to my bill of materials. So I had to eliminate them all and then re-balloon the view. And once I did that, now I've got balloons pointing to each one of the parts that make up this assembly. Once again, you know, why do that when I can point to this guy and be done. So it's still item 7. The nut, I still need 2 of them. So now let's modify this guy one more time. Go to indented. And so now my part numbers, my parts don't have item numbers, but my assemblies do. And again, it's 1, 2, 3, 4. And if I look at my balloons, I'm not really I have more balloons than I need, but my numbers have updated so that they correspond to the item numbers that are in the chart in the bill of materials. So I've got 2 1s, right? Because they're both part of the. I've got 2 2s, 1 3, and 1 4. I'm sorry, 2 3s and 1 4. Could I leave it like that? Probably. I could probably leave it like that, and somebody would be able to figure it out. But I suppose, you know, really the best thing to do would be to eliminate the balloons. Oops. And just redo it. You know, it doesn't take much to do. And now my numbers, you know, and I've got 4 balloons again to match the 4 items in the bill of materials. And if I were to go from this back to my top level only. Everything's, I don't have to make any changes because I didn't change the item numbers. These are, they should be, the information in each one of these cells should be based on links back to can't think of the word. Characteristics of the, for lack of a better, the correct term, characteristics of the drawing. So if the drawing has a title that says swivel brace assembly, that's probably where it came from. Or if the part itself has it, I don't know. My point is, if you go to change any of this, if I want to change this description, I'm going to get a notification that says that cell value is linked to a property in an external model. You want to keep the link or break the link and override the value. If you break the link, you can restore it by clearing the cell. So if I say break the link, now I can change the text and call it, say, just say, I like, for some reason, I forgot the U. I want to call it swivel brace subassembly. And do the same with all of these. I can do that. And I think if I double click this guy, it's going to give me that same message again until I check this. And I maybe don't want to check that. I don't want to break the link on that one. And so if I want it to be associated with a property, again, like it was, I have to clear the cell. So I just deleted everything and then click outside here. And you see now the text is reverted back to the linked property that's part of the part file. If I were to open up that, that assembly, let's go ahead and open. That was assembly 3, subassembly 3. There's the subassembly. So I want to know what the properties of this thing are. So let's see if we can find out. So here's where the summary information. Here's where that information is coming from. It's coming from. I went to File, Properties. This gives me the properties of the file. This is the value for the description of this part. Swivel brace assembly. And the property name is description. And I can add as many properties to this as I want. I can add material, blah blah. What else can I add? The part number. There's a whole finish. A whole gamut of information that you can add. They become properties and values in the drawing that you can link to other files. So if I were to change this and say, and make it say that I want this to be sub assembly and say OK. Now when I go back to the assembly drawing, notice it's updated and it now says swivel brace sub assembly. So that's proof that it's linked back to that assembly file. Any questions on that? I'm looking at the, if you guys were asking me, if you or Bob were trying to ask me a question on the chat, I had the instructions up and I wouldn't have seen it. So, and then once I can move this around wherever I want it. I can move obviously this drawing view anywhere I want. Like I said, you can arrange and rearrange the balloons, change the style. If I want to change them all to, the only way I know to change them all, say to split balloons would be to highlight each one of them to go to the property manager and hopefully it's not giving me, when I did this, let's see, when I did it yesterday, I didn't have any issues changing them to split balloons. Even now, it's giving me a different, oh, I guess it's, never mind. I'm confused because I was changing them when I first placed them this morning. So if I select all these balloons, and I can go to the settings here, and I can call it I can call them circular split line. It'll change them all to circular split lines. And it says 2 characters, and it should say what the upper and lower text is, item number and quantity. I can change those. So I can kind of do it on the fly, but there's no way to, to attack. If you have like 100 balloons in here, there's no way to attack them as a group that I know of. You have to pretty much highlight them all to change them if you want to make a major change like that. Sometimes the easiest way to do it is to just blow them all away and reinsert them, and in the process of reinserting them, change the settings that you want to change, depending on how many you have. So are there any questions on that? That's it. That's the whole thing. Any questions on any of the homework? The only thing that I would like to do is to go over this chapter 9 practice a little bit. The homework says to do page 919, problem 9-1. And if you look at that, this is the problem. This is the assignment. It says, what's the name of the assembly? And if you go to the next page, all you have to do is pick all this stuff out of the drawing. If you are, if you're doing this and then turning it in, rather than for the last two, the last 2 questions, ask you to circle the adjusting nut and then circle the hex nut. Instead of doing that and having to print out the picture and show me that, just give me the item number. You give me the item number of the hex nut and the adjusting nut, that's good enough. Then you don't have to include the picture of the drawing to circle. So just do that. Just give me the item number, and we'll call it a day. I think I need to change this to include a text entry for probably 1 or 2 folks that won't be able to scan it and turn it in. So when I leave you guys, I'm reminding myself to do that right away. I think that's it. I appreciate your time. Have a good weekend, and Monday, if we need to continue on this, we will. Otherwise, if you have questions about SolidWorks, whether it's part files or drawings or whatever, send them to me in an email, and so maybe I can go over them. I can figure out how to do it, since some of the stuff I haven't worked with in a while, and then we can go over it on Monday, because I've got some setup part files that I can show you a few of the techniques that make SolidWorks kind of interesting. So if that's it, I'll see you guys on Monday, and it'll be the same password that we're using today. I don't want to go back and try to figure, because I won't be able to figure out that the old password, I don't think. I mean, I could probably go back to some of the emails that I sent out and find it. But, that'll confuse half the people that already have decided they can use the new password. So let's just see how it goes. All right, thanks again. I'll see you on Monday.